So these double square root equations, we still need to state the domain, but we will only focus on the inside domain, and which is an incomplete domain restriction. Okay, so we cannot use that domain inside only domain restriction to establish extraneous solutions. So we're going to have to test these. So let's state our inside domain restriction first. Okay, so x is going to be greater than or equal to -10. Here, x is going to be less than 2. Okay, so if we have x is equal to 2, we end up with 0. Now, if we let x equal to 3, we end up with negative, so we have to have x less than 2. Okay, so then our domain restriction, when we put these two together, we have to be bigger than -10 and less than or equal to 2. Okay, and again, this is only an inside restriction, so although we could determine if it's extraneous, if our restriction is falling outside, or sorry, if our solution is outside this domain restriction, this is an incomplete domain restriction, so we can't say that just because it's inside, it is a valid solution. Okay, so we're going to have to test these, but I do expect you to be able to find an inside restriction for these square roots. So we're going to go ahead and solve this then. So we need to isolate one of the square roots. I'm going to move this square root to the other side. I'm going to get rid of this square root first. And again, whenever you square these binomial terms, you have to make sure you distribute out correctly. So 10 plus x, we end up with square root of that squared, so we end up with -2x plus 4 minus 2 minus 2, so -4. And then -2 times -2 gives us a +4. Okay, so then I'll move this term to this other side, so I end up with 4 square root -2x plus 4. So I'll move this to this side, so I'm going to subtract an x, so I get -3x. Subtract 10, so I get +4 plus 4 minus 10 is -2. Okay, so we have those two solutions here, or sorry, we have these square root, second square root that we want to get rid of. So we're going to square out that and square out this. So we end up with 16, -2 plus 2x plus 4. When we distribute this, we get 9x squared plus 3x times 2 is 6x, so we have two of those, plus -2 times -2. So here's our quadratic. Okay, so we're gonna, maybe I'll show a few more steps here, so that's gonna be 64. We need to make it equal to 0. Okay, so I end up with 9x squared plus 44x minus 60. Ooh. Okay, so this may be factorable. Maybe we should just take a quick look, see if it is factorable. I think we end up with, that's going to be 540. That looks, well, that looks a little bit complicated. I think maybe we'll just use a quadratic formula. Well, those are big numbers. Okay, well, maybe we should just double check here because this may not be that hard to factor. Okay, so we end up with 9x squared, -60. That's going to be -540x squared. So we're looking for Factors of 540, yeah, that looks like it'll be factorable. So 10 times 54 will give us, so we should end up with negative 10x positive 54x. Okay, so then when we factor this, we end up with negative 10. This is going to be 9x. This way is going to be just x, and the common factor this way is going to be positive 6. Okay, so it looks like that will give us our, just double checking, yeah, that looks like it's going to factor. Okay, so we end up with 9x minus 10, x plus 6. Okay, so x is equal to 10 over 9 and negative 6. Okay, so we should test these solutions. Okay, so when we test, we're going to test, let's test the easy one first, negative 6. So we end up with square root 4 minus, that's going to be positive 12 plus 4 is 16, plus 2 equals 0. That's 2 minus 4 plus 2 equals 0. Check. That is a good solution. Okay, we're going to test 10 over 9. Okay, this is, we could use a calculator for this, but I'm just going to plug it in the way it is. So 10 over 9 is going to give us 100 over 9. So that's going to give us 90 over 9 plus 10 over 9, which is 100 over 9 minus, that's going to be 4 minus 20 over 9, so that's going to be 16 over 9. Okay, so that's going to be 36 over 9 minus 20 over 9. And that's going to be plus 2 equals 0. What's that going to be? That's going to be 10 over 3 minus 4 over 3. Now you could do this on your calculator too, but I'm just going to do it since it's all fractions. I'm going to just do it by hand. So we're going to end up with 6 over 3 plus 2 equals 0. That's not true, okay, because 2 plus 2 is not equal to 0, so we know that this one is extraneous. Okay, so that's our extraneous solution here. Okay, now we can double check this by graphing again, and maybe if we will double check this by graphing at the end, because it's especially if you're working on this at home, it's good to check these things and see if you've done something wrong, and then you can go back through your steps. Now there's a lot of algebraic steps here that we could have easily made a mistake. Okay, so your graph never lies to you, so you can always check your answers on your graph. So this last one here, we're gonna again state our domain first. Our domain restriction is going to be x is going to be less than or equal to 10, and x is going to be greater than or equal to negative 3. So our domain together is going to be between negative 3 and positive 10. Okay, so again, this is just the inside restriction. This is not a complete domain restriction because there is still an outside restriction that we're not considering, okay, which is much more complicated. We don't expect to be able to do that. So we're going to isolate one of the square roots. Okay, and then we'll undo the square roots with the square, remembering to FOIL out that. Remember to expand that out correctly. So we end up with 10 minus x, 1 plus, we're going to have 2x plus 3's, and then root x plus 3 times root x plus 3 is just going to give us x plus 3. We'll combine our like terms, so here we're going to subtract 4, so we're going to end up with 6. Subtract an x, so we're going to end up with minus 2x. Okay, so just double check our accounting. -1 minus 3 is -4, so we get 6. Minus x is going to give us negative 2x. Now, this extra 2 we can get rid of by dividing both sides by 2. That just simplifies the equation and makes it a little bit easier to work with. We'll get rid of the second square root by squaring. Again, it's a binomial, so make sure you expand out that binomial correctly. Okay, it's a quadratic equation. Subtract x from both sides. Subtract 3 from both sides. It is factorable. So we end up with our two solutions, 6 and 1. Okay, so we're going to, again, we can't rely on our inside domain only. So we actually have to test these. Okay, with the double square root equations, we have to test. So x equals 6. We're going to end up with 10 minus 6 minus 6 plus 3 equals 1. 2 minus 3 equals 1. That's not true. That's extraneous. Okay, so that's an extraneous solution. We'll test x equals 1. We end up with square root 9 minus square root 4 equals 1. 3 minus 2 equals 1. Yeah, 1 equals 1. That one is our good solution. Okay, so there it is. Just a reminder, we do expect you to come up with the inside restriction. However, this is an incomplete restriction, so notice that this x equals 6 actually passed this restriction, but because it was only an inside restriction, it's incomplete. We can't rely on that to do check for extraneous solutions on the double square root equations. Okay, that does work when we have both inside and outside restrictions, but not when we only have the inside restriction.